And first about this question, is asking us the determine resulting internal the loading acting， 所以它要算内能。And how to calculate the internal loadings acting, and we draw the free body diagram like this. So the distributed load we calculate see it into the force here and another force here. So it's another is force here, and the length is 2, 1 and 2 here. And now if we summation B and B here is equal to 0, we can get the FA because of this, and times 2 and plus 6 times 3.5 is equal to FA times 4. So FA is 7.5. And summation B and A, and A is equal to 0 here, and also plus 6 times 0.5 and is equal to 4. FB here. So FB is 3, FA is 7.5 here. And it says we have to see acting on the cross section at point C here. So we draw also the free body diagram here, C, and we get this FC here, and also the internal MC here and NC here, and the force 6 here, and the FA here 7.5 here. So if summation Fx is equal to 0 and NC is also equal to 0, and if the summation Fy is equal to 0 and 6 plus Vc is equal to 7.5 here, so Vc is 1.5 kN here. And if summation Ma is equal to 0, so 6 times 1.5 and plus 1.5 times 1 is equal to MC. So MC is equal to 4.5 kN here. And the next question also it determined this one, but we have to see in the point D here. So we also draw the free body diagram, point D here, and ND we don't know, and VD here, and also the MD here. And this is 1.125. And this one is 1, and this one is 0.5 here, and B here, and we know the FB here is 3. So also the summation Fx, if that equal to 0, and D is also equal to 0, and summation Fy is equal to 0, and Vd plus 3 is equal to 1.25, and the Vd is minus 1.875 kN. And also summation MB is equal to 0, so MD minus times 1.5 is all equal to this times 1. So MD is equal to 3.94 kN. This is the answer. Okay, and this question is easy. It just asking us to determine the range shear stress in the pin, and we know the function of shear stress as VA here. And if we look from this side, it will be like this, and 3 kN here, So this 2 is 1.5 kN, 1.5 kN here. And the function is, it also says 4 mm diameter. So at 4. That's what we need. And this question, we divided this into 2 different parts, and this part and this part here. So basically, we started from this part first because we need to calculate the BC here. And so if we want to know the BC here, it's 0.8, and we have to use if summation MA is equal to 0. So this one, 3W, and times the length, and plus BC. And because we know it's theta, sine theta, and times 3 is equal to 0. And the theta here, because the question tells us is 3, 4, 5, and the theta here. So the theta is minus. So this is this. And we calculate this, BC equal to 1.875 W. And the W is what we want to calculate. And also, and the second part here, theta and the BC here is 1.75 W. And now this has the BC here, the MC here, and the NC here. So if the summation Fx is equal to 0, and the VB here and VC here, plus this, and times sine with 3 point equal to 0, so BC is equal to 1.5 W. And if summation Fy is equal to 0 and NC minus NC plus this times cosine, and it's equal to 0. So the NC here is W. And then so BC, NC, we know the here, and we use those functions because the questions already tell us if this equal to 15 and the tau equal to 13 MPa. And use this function, we can calculate the W here. We use this too. And A here is the area. And if cosine times 33, we draw the picture like this. 30, and it's x. So we know the x is equal to m. And the length is also tell us, so we can know the area is equal to times m here W in the area, and the W here is equal to this, and W here is equal to an M. So basically, we can know the answer. We can know the answer is this. And the next question, it says determine the positions D here. And so basically we started from the summation MA, if that is equal to 0, and the CD times 3 minus D. So we know CD is equal to 2D. Okay. And if this summation Fy is equal to 0, so AB plus CD and is equal to 6. So AB here is 6 minus 2D. Okay, and so, and basically it says this AB have to equal to this CD. So now we calculate this here, use this function AB is equal to minus 2D times 10, 3, and 12 pi D. And pi 12 times 4. And this CD is 2D times 10 and 3 and pi A squared 4. So basically this one is the same, so we can know from this one we can know like 48 minus D is 24D, and 24D plus 60D is 48D. So D is equal to this. So it's equal to 1.2 M here. And then this one, it says we have to determine the average normal stress in the bar, and as a function of x for this. And basically this one we have to calculate nx here first, and this here is a distribute load, but it's a triangular axis distribute loading, so it will be like a triangle. And then here is x, and here is x. We don't know the x here. And the area. So basically the area is like this, 1.5 times. So it's 3 here. And because of this, we can know the nx here is equal to 4 plus 8 and plus 3, and x here is the total length, so it will be like 1.5 here. So here is 18. This one. But basically, if we want to know the f in this limit, so we use this function as f area here, and f we know as this, but in this area, so we have to minus this. So A, the quotient also give us. So it will be like 46.9 minus 7.5x 2 square MPa. This is what we need the answer. And then this question is asking us to determine their required diameters. And it also gives us if this is equal to 150 MPa. So we know we can use this function PA here. But basically we have to know the area here so we can know the D here. But we start from the P here first. If summation Fy equal to 0, so minus 20, P is 20. 20 and plus, and the angle is 45. So we know here is AB. We know FAB is equal to this. And if summation Fx equal to 0, so minus FAC plus this. FAB equal to 0. So FAC is 20. Okay, and we use this function FAB. AB. And we know the FAB here, this one is 150 equal to FAB here, because it's Kn, so we have to times 10.3, and the area here D2, so we know the D here is 50.5 mm. And this one also, FAC, AAC here, is equal to 20 times 3 pi for D here. So the D here, the AC is 13 mm. And now next question, it says determine the average normal strength in the when it is stretched to the position shown. So we use this function to see this. And basically we don't know the x here, but we can calculate in the math way. So the change L here, it will be 2 times x because we have 2. And here it will be like 8 point this. And the question is also tell us if the unstructured length of the floating through is 887.5 here. So we use this function here. We all know this. So it's equal to 0.0689 mm. And first of all, we know the cushion is determine the shear strength gamma xy at the point A, B, and DC. And because the change of A, B, C, D is quite the same, because of the angle here is all change the same here. So basically we can know if the gamma A xy is also equal to 0.79 plus any times, because we need the RAD here, so it's equal to 0.0116 RAD, and it's also equal to gamma A, gamma B, gamma C, and gamma D, because the angle of ABCD it changed the same, so the gamma here is all the same. And then the next question, it says determine the average normal strength that occur along the diagonals AC and DB. So DB here is we use this function minus L0 because the length is all equal to 500 here. So we calculate this, and it will be like 3 plus and it's 4 minus 500 and it's 4. So it will be 6.4 and 500 and it's 0.0128 mm and mm here. And this one also AC here, and also the same function and 500. And this one is equal to 400 and minus 2 and plus 3. And the 300 plus 2 and minus 2 and minus 500, and you will like 500.8 minus 500 and it's 0.8. So here is 0.8 and 500, and the answer is 0.00016 mm and mm here. Is this the answer? And first of all, it says this question is asking determine the change in this length and the change in this diameter. So basically we can use this function to see the change, this one here. So basically we can write down here and NA here, and then the question is already tell us it's 300 minus 0.450 and it's equal to 1.7 MPa here. And we use this into this function, so E here is 1.7 and this. And E already tell us it's 2.7 times 10, 9 here. So we can get this. Here is 6.3 times 10 minus 4. So this, we also use this. So L, it will be use. And the original length is 200, so it will be like 200 and times this. And the answer is 0.126 mm here. So it's the change length. This is one of the answer here. Also, second, it asking us the change the diameter of this. So we also use this function, LAT and the LONG here. So if LAT is equal to minus V times LONG here. So it will be like 1 minus, it also give us here. And times the here from the last question. So LAT will be minus 2.52 times 10 minus 4 here. And you also use this function equal to D and the D here. So this D will equal to D times LAT. So the original D is 15 and times this. So it will be equal to minus 0.0038 mm here. And then this one is asking the determine the strength X and Y and the gamma XY here. So basically we use this function and we know the question is also give us this first, and the length here is 400, so it will be 4 mm. So this is what we need, and also use this function minus LAT ONG. So basically we know the AT is minus V LONG here. X we all know here, so minus 5. The question gave us, and just what we calculate, and it's minus 0.00375 mm. And here. So this is what we need, this and this one. It's easy, the answer of these two. So we have to calculate the gamma. And the gamma, it tells us the function is this. And the theta also give us. So we just have to calculate it, and from the theta to RAD. So it will be 0.0122 RAD. Here's also the answer. And now the last question is tell us determine the approximate vertical displacement of the plate due to the shear strength in the rubber. So basically asking this, what is this? And the detail we can know is like A is times this. So the area will be like this. Because if we need this, we have used this function. And we don't know like this one. And this one is easy. So it will be like we use tau PA here. So the P here is 2.5 and the area here. PA here. And also this function. And G also give us is 0.2 MPa, so it will be like PA. And this one. So the RAD will be like this. And we know the here, so this one will be like times 40 A3 and times 40 because of this equal to L. So L is 40 here, and this one is also the gamma here. So we put in gamma here, and we can know the answer is 0.833 mm is what we know the final answer.